Hello everybody. In this video, we're going to discuss how to find a plane equation given 3 points. This discussion is to prepare the triple integrals where we often face with a plane equation going through 3 points. So it's a preparation of the following the following questions. So we're going to discuss how to find an equation of a plane going through 3 given points in R3, so 3D-dimensional space. So it's to prepare triple integrals. Alright, so there are a few notations we want to recall. So usually in R3, we take basis of R3 or three special vectors, most important vectors, as 1, 0, 0. This is unit vector lying on x-axis, which is I, and 0, 1, 0, which is denoted by J, and 0, 0, 1, which is denoted by K. So IJK stands for three special vectors, and then that means we can write any point in R3 as combination of these bases. That's what basis means. So for example, if you have like A, B, C, this is a point with x coordinate, y coordinate, z coordinate given by three numbers A and B and C, then you can always write this as AI plus BJ plus CK. So whenever you look at this, you should recall this. So vice versa. If you have this, you can write this too. Now the dot product is just component-wise product and take the sum. So we're not going to write this here. But another, so you can write what dot product means. So I'm going to skip. But the cross product is different. Cross product, if you have two vectors, so u v, dot product is, and let me write the notation, dot product is u dot v, which is component wise. And this one is different. It's, so this is a number, but this is a vector. It gives a vector. So what kind of dot product it has? So if you have x1, y1, z1, which is u, and another vector x2, y2, z2, which is v, then this cross product is given by ijk, x1, y1, z1, and x2, y2, z2. In other words, this is determinant 3 by 3 matrix, right? So you need to know how to solve that, how to compute the determinant. So we recall linear algebra. So if you have determinant of 3 by 3 matrix, then you can actually screen down co-expanding. It's called co-expanding, or screening the first row, and you can write the plus minus plus. So flip the sign. So mark those signs, plus, minus, plus, and then we can expand this. So for I, this is plus I, so I don't need to write plus. And determinant of its minor, which means the submatrix, determinant of submatrix, taking out, removing first row and first column. So I row and I column. And then we do negative, because for J, it is attached with negative sign. And then its minor means you remove J row and J column, then you have 4 numbers here. So that submatrix determinant is x1, z1, x2, z2. And then now it turns to the last one, plus k. So plus k, and if you remove k row, k column, then we end up with this submatrix. So this is x1, y1, x2, y2. And 2 by 2 matrix, its determinant is just straightforward. So y1, z2 minus y2, z1. And here this is x1, z2 minus x2, z1 plus k x1, y2 minus y1, x2. So this is the formula for cross product. And the meaning of cross product is that, suppose if you have u and v, two vectors in R3, so suppose u and v, right? Then of course you can span u and v to make a plane going through u and v. So by using these two arrows, you can make a plane going through u and v. And u cross v, it is another vector which is perpendicular to this plane. So both u and v. In other words, so this is span of u and v, perpendicular to span. Span means the plane going through u and v. So this is u cross v. Oh, this is u this here and v is here. Now we are going to look at one example. Suppose u is given by 1, 1, 0, v is given by 0, 1, 1. What is u cross v? Then I, j, k, and 1, 1, 0, 0, 1, 1. Its determinant is I times 1 minus j times 1 and plus k times 1. So it is I minus j plus k. Or you can think of this as I coefficient is 1, j coefficient, and k coefficient. So this is another vector, and you can see that this one dot product to this is going to be 0, and this dot product to this is also going to be 0. So this vector is perpendicular to both u and v. Alright, what is then the final question? How to find a plane equation going through 3 points Then the strategy is following. So suppose PQR is here, then what you do is you first find two vectors, PQ and PR. So first you want to find U equals PQ, starting from P going to Q, which is basically Q minus P. So Q minus P is just these three number minus these three number component wisely. And you also want to write, so this is U, this is V. V is PR, right? So R minus P. So given 3 points, it's not hard to find U and V by just subtracting to each other. And then you want to find its cross product U times V, which is can be computed by formula. And then, so suppose we say this is W, right, if you compute. And then we know that any point, suppose this is any point, so any point on this plane going through PQR, if you connect them, this is also going to be perpendicular to this. So suppose this point is X, Y, Z, right? Then this arrow is X minus X0, Y minus Y0, Z minus Z0, and dot product to W must be 0. This is the equation for the plane going through PQR. So we are going to look at one example. So find equation of the plane going through 0, 0, 0, 1, 1, 0, and 0, 1, 1. So you can think of this as P, is a Q, this is R, right? So first we find that U equals QP is basically 110, right? And V equals R minus P, it's 011. And then W is U cross V, which is IJK 110011, which was solved here. So we already solved here. It's 1, negative 1. So which is 1, negative 1, 1. And then the equation is that X, Y, Z minus X0, Y0, Z0, which is 0, 0, 0, equals 0. So that means 1, negative 1, 1, and dot product X, Y, Z equals 0. So component-wise multiplication gives this. This is the plane equation. It's good to test if by plugging in these three PQRs. So for example, P 0, 0, 0, 0. If this is on this plane, if when you plug in these three numbers to X, Y, Z, it satisfies the equation. So you can try PQR by plugging in component-wise, so X, Y, Z, and see if this actually goes through, satisfies these equations. All right, this will be helpful for at the end for triple integrals for some examples. All right, we stop here.